Welcome to GeoVenture. Please like and subscribe to the channel for more fascinating journeys. Let's begin. Think of the most extreme place you know on Earth. Perhaps it is the crushing pressure at the bottom of the ocean, or the bitter, unending cold of an Antarctic winter. These places push the boundaries of what we think is possible. But when we lift our gaze to the cosmos, we find extremes that dwarf anything on our own small world. The universe is a canvas painted with impossible temperatures, unimaginable speeds, forces so powerful they bend the very fabric of space and time. It is a place of profound beauty, breathtaking violence, where the laws of physics are stretched to their absolute limits. We are about to embark on a journey to visit some of these incredible locations. Our cosmic tour will take us from the quiet, absolute chill of interstellar space to the mind-bending fury at the edge of a black hole. We will not be moving in a straight line across the galaxy, but rather on a journey of increasing intensity. Our first stop is a place of profound and almost absolute stillness. It is called the Boomerang Nebula, and it holds the title of the coldest known natural place in the universe. Located about 5,000 light-years from Earth, this cloud of gas and dust has a temperature of just 1 degree Kelvin. That is minus 272 degrees Celsius, or minus 458 degrees Fahrenheit. It is only a single degree above absolute zero, the theoretical point at which all atomic motion would cease entirely. This is a cold so deep, so complete, that it makes the harshest winter on Earth seem like a balmy summer's day. How can a place in space become so incredibly frigid? The Boomerang Nebula is what is known as a pre-planetary nebula. At its heart is an old, dying star that has been shedding its outer layers of gas for thousands of years. This gas is expanding outwards at a tremendous speed, about 164 kilometers per second. This rapid expansion acts like a cosmic refrigerator. Just as the expanding gas from an aerosol can feel cold, the gas in the nebula cools down dramatically as it rushes into the vacuum of space. The star's own light is not enough to warm this vast, fast-moving shroud. Now we move from the impossibly cold to a place that is strangely in between. Let us visit a brown dwarf, a fascinating object that blurs the line between a planet and a star. Brown dwarfs are often called, failed stars. They are born from collapsing clouds of gas and dust, just like true stars. However, they never accumulate enough mass to ignite nuclear fusion in their cores. They do not have the gravitational might to start burning hydrogen into helium, the process that makes our sun shine. As a result, they are left in a state of cosmic limbo. More massive than Jupiter, but far less luminous than the smallest stars. A brown dwarf is an extreme place not because of one single quality, but because of its strange combination of properties. After its initial formation, it simply cools down for the rest of its existence, glowing faintly in infrared light from its residual heat. Some cooler brown dwarfs can have surface temperatures similar to a pizza oven, around 480 degrees. Incredibly, the coolest one ever found, named WISE ZU8550714, has a temperature estimated as low as 20 degrees. Leaving the cosmic twilight of brown dwarfs behind, we now journey to a place of overwhelming light and power, a blue supergiant star. These are the rock stars of the stellar world. They are incredibly massive, often containing dozens of times the mass of our own sun, and they live their lives in the fast lane. Because of their immense mass, the gravitational pressure in their cores is tremendous, causing them to burn through their nuclear fuel at a truly astonishing rate. A blue supergiant might exhaust its entire fuel supply in just a few million years, a mere blink of an eye compared to the sun's expected lifespan of 10 billion years. The defining feature of a blue supergiant is its extreme heat. Their surfaces sizzle at temperatures of 20,000 to 50,000 degrees Celsius, making our sun's 5,500 degree surface seem lukewarm in comparison. This intense heat gives them a brilliant blue-white color, They can outshine our sun by hundreds of thousands of times. If you replaced our sun with a blue supergiant like Rigel, the seventh brightest star in our night sky, its searing radiation would instantly boil our oceans and strip away our atmosphere. Proximity to one is a death sentence. These stellar behemoths are incredibly violent and unstable. They blast powerful stellar winds into space, shedding vast amounts of their own mass. When a massive star dies in a supernova, it can leave behind one of the most extreme objects in the universe, a neutron star. Let us focus on a special type called a pulsar. A pulsar is a rapidly spinning neutron star that acts like a cosmic lighthouse. It is an object of almost unbelievable density. Imagine taking a star more massive than our sun and crushing it down into a sphere just 20 kilometers across, about the size of a city. A single teaspoon of matter from a pulsar would weigh billions of tons on Earth. This is matter squeezed to the absolute brink, just one step away from collapsing into a black hole. What makes a pulsar truly extreme is its combination of rapid rotation and intense magnetism. As the original star collapsed, its rotation speed and magnetic field were hugely amplified. Some pulsars spin hundreds of times every second, faster than the blades of a kitchen blender. This rapid spin generates powerful beams of radiation that sweep across space. Its magnetic field is trillions of times stronger than Earth's. If one of these beams happens to point towards Earth, our radio telescopes detect a regular pulse, which is how these objects got their name. They are some of the most precise clocks in the universe. Now let us turn the dial up to an even greater extreme. A magnetar is a rare and terrifying type of neutron star with a magnetic field about 1,000 times stronger than a typical pulsar. This makes it the most magnetic object we know of in the entire universe. Its magnetic field is so powerful it would be lethal from a distance of 1,000 kilometers, as it would distort the atoms in your body. We have now arrived at the end of our journey of extremes at a place where the known laws of physics break down completely. We are at the edge of a black hole. This is not a place of matter in the traditional sense, but a region of space-time where gravity has become so overwhelmingly powerful that nothing, not even light, can escape its grasp. The boundary marking this point of no return is called the event horizon. Crossing it is a one-way trip to an unknown fate. A black hole is the ultimate cosmic prison, a place where gravity always wins. The experience of approaching a black hole would be the most extreme imaginable. As an object gets closer, the difference in gravitational pull between its near and far side becomes immense. This tidal force would stretch the object vertically while compressing it horizontally, pulling it apart into a long, thin stream of atoms. This gruesome process has been nicknamed spaghettification. Black holes come in different sizes. There are stellar mass black holes formed from the collapse of a single giant star. Then there are the supermassive black holes, true monsters that lurk at the centers of most galaxies, including our own Milky Way. Forming a swirling, superheated accretion disk around the black hole, this disk can glow brighter than all the stars in the galaxy combined, creating a brilliant beacon known as a quasar. These objects are not just cosmic vacuum cleaners. They are engines of creation and destruction that shape the evolution of entire galaxies. A black hole is the final word in extreme, a point of infinite density and zero volume where our understanding of reality simply ends. The universe is an endless source of wonder, and its most extreme places are its most powerful teachers.